Science is cool, it's all around us. From the smallest atom to the largest star, science explains how things work. Imagine the tiny particles that make up everything we see, touch and feel. These atoms combine in countless ways to form the world around us. And what about the vast universe? Stars, planets and galaxies all follow the laws of physics, making the night sky a giant puzzle waiting to be solved. Ready for a science quiz? Let's test your knowledge and learn some fun facts along the way. Did you know that water expands when it freezes? Or that lightning is hotter than the surface of the sun? Science is full of amazing discoveries and mind-blowing facts. So buckle up and get ready to dive into the wonderful world of science. Whether you're in a classroom, a lab, or just gazing at the stars, there's always something new to learn and explore. What's the basic unit of life? It's the cell. Cells are tiny, but they make up everything living. Your body has trillions of cells. What's the powerhouse of the cell? It's the mitochondria. These little guys provide energy for the cell to do its job. They're like tiny power plants. How do plants make food? Through photosynthesis. It's like magic, but it's science. Plants use sunlight, water and carbon dioxide to make their food, releasing oxygen as a bonus. Section 5. Fueling our body's carbohydrates. What's the primary energy source for our cells? It's carbohydrates. Think of them as fuel for our bodies, giving us the energy to move and think. Section 6. Roots, nature's water and nutrient collectors. What part of the plant absorbs water and nutrients? The roots. They act like straws, sucking up water and minerals from the soil to nourish the plant. Section 7. DNA, the blueprint of life. What does DNA stand for? Deoxyribonucleic acid. It's the instruction manual for building and running a living organism. Your DNA is unique to you. Section 8. The circulatory system, our body's delivery network. What's the primary function of the circulatory system? To transport nutrients and oxygen, it's like a delivery network ensuring every cell gets what it needs. Section 9. Red blood cells, oxygen heroes. What type of blood cell carries oxygen? Red blood cells. They're like tiny ships carrying oxygen from your lungs to the rest of your body. Section 10. Mitosis, cell division and growth. How do cells divide and multiply? Through mitosis. It's a process where one cell divides into two identical cells, allowing for growth and repair. Section 11. The nucleus, DNA's protective home. Where is the genetic material located in the cell? In the nucleus, it's like the control center of the cell, protecting and organizing the DNA. Section 12. Water, the elixir of life. What's the chemical formula for water? H2O. 2 hydrogen atoms and 1 oxygen atom make up this essential molecule for life. Section 13. Covalent bonds. Sharing is caring in the atomic world. What type of bond involves electron sharing between atoms? A covalent bond. It's like atoms holding hands, sharing electrons to form a strong bond. Section 14. Sodium, a tiny element with a big impact. What element does the symbol Na represent? Sodium. It's a common element found in salt and is essential for our bodies to function properly. Section 15. Acids, bases and the pH scale. In this section we will explore the fascinating world of acids and bases and how the pH scale helps us understand their properties. What's the pH range of an acidic solution? 0 to 7. This means that any solution with a pH value less than 7 is considered acidic. The lower the pH, the stronger the acid. Acids are sour, like lemon juice. They can be found in many everyday items, from the citrus fruits we eat to the vinegar we use in cooking. Acids play a crucial role in various chemical reactions and processes. Bases are bitter, like soap. Bases, also known as alkalis, have a pH greater than 7. They are commonly found in cleaning products and can neutralize acids. Bases feel slippery to the touch and are essential in many industrial applications. The pH scale measures how acidic or basic something is. It ranges from 0 to 14, with 7 being neutral. Understanding the pH of a substance is important in fields like chemistry, biology, medicine, and environmental science. Scientists use pH meters and test strips to accurately determine the pH of various solutions, ensuring safety and effectiveness in their work. Section 16. Photosynthesis. Plants exhaling life. What gas do plants release during photosynthesis? Oxygen. They breathe in carbon dioxide and breathe out oxygen, just like we do the opposite. Section 17. Atoms, the tiny building blocks of matter. What's the smallest unit of an element? An atom. Atoms are incredibly small, but they make up everything around us. Section 18. Citric acid, the zest in our lives. What acid is found in citrus fruits? Citric acid. It's what gives lemons and oranges their tangy taste. Section 19. Combustion, the fire within. What type of reaction with oxygen produces heat and light? Combustion. It's what happens when we burn wood or light a candle. Section 20. The periodic table, organizing the elements. What's the name of the table that organizes all the known elements? The periodic table. It's like a giant map of all the elements in the universe. Section 21. Noble gases, the lone wolves of the periodic table. Name a noble gas. Argon. Noble gases are not very reactive, like loners in the world of elements. Section 22. Force and Newton's laws, the science of motion. What's the unit of force in the SI system? The Newton. It's named after Sir Isaac Newton, who figured out a lot about force and motion. Newton's contributions to science are monumental. He formulated the 3 laws of motion, which are fundamental to understanding how objects move. The first law, often called the law of inertia, states that an object will remain at rest or in uniform motion unless acted upon by an external force. The second law explains how the velocity of an object changes when it is subjected to an external force. This is often summarized by the equation F equals sine mr, where F is force, m is mass, and a is acceleration. The third law states that for every action, there is an equal and opposite reaction. These principles not only apply to everyday objects, but also to celestial bodies, helping us understand the motion of planets and stars. Newton's work laid the groundwork for classical mechanics, a cornerstone of modern physics. Section 23. Speed of light. The ultimate speed limit. What's the speed of light in a vacuum? 300,000 kilometers per second. Nothing travels faster than light. Section 24. Kinetic energy. The energy of motion. What type of energy is associated with motion? Kinetic energy. The faster something moves, the more kinetic energy it has. Section 25. Electrical resistance and Ohm's law. What's the unit of electrical resistance? The ohm. It measures how much a material resists the flow of electricity. Section 26. The importance of science in our daily lives. Science is important. It helps us understand our world and make better decisions. Keep asking questions and exploring the wonders of science.